For these next two reactions, when we look at the reactant sides, we notice we have a single element and then a compound. And then down here, we also have a compound and a single element. When we go back to our chart up here, this is what we're going to call a single replacement reaction. We have an element that is replacing one of the ions within the compound. Now, if you look, there are two different types of single replacements. The first one shows A as a positive ion or a cation. That means the A and the B are going to switch places. And then the second type of reaction, the individual element would be a negatively charged element, so that when it replaces the element within the compound, the element that was by itself is a negative charge. So we'll see that the new element is also going to be a negative element. So that's the difference here. And I'll show you what I'm talking about on these two. These are single replacement reactions. So we're going to determine right now which one of these we're using. We look at Al, and Al is a positively charged ion. That's aluminum right here with a 3+. That means aluminum will be switching places with the Pb, the lead. That means on the right side, we can go and write this part now. Al is going to pair up with NO3, but we want to make sure that this is neutral, and that means we need to check our charges up the top. We just saw that Al is a 3+. If you don't remember NO3, NO3 is nitrate. It's going to be up at the top of the list up here, and nitrate is this one right here, NO3-. It just has a single charge. Therefore, when we write this, if that's a 1-, we're going to need 3 total nitrates to make sure that that's electrically neutral. I can erase my charges. We don't want to write our charges whenever we're showing our formula. That's aluminum nitrate. If the aluminum replaced the lead, now the lead is going to be by itself, just like that. And then we can go back in and balance this one. We can see that there's 1 Al on the left, 1 Al on the right, 1 Pb on the left, 1 Pb on the right. Now we need to go ahead and balance our NO3s. Since this is 2 and this is 3, we can use 6 as our common factor for that, or those are the factors of 6. Therefore, I'm going to go ahead and put a 2 here and a 3 there. That will take care of my nitrates. And then we can just go back in and put our 2 for aluminum and then our 3 for lead. And that will take care of that. For this next reaction down here, we're going to look at our single element again, and we're going to determine what it's going to replace. If we find F up at the top of our chart here, F is a negative ion. Fluoride is a negatively charged ion. Therefore, the F on this one will be replacing the Cl. We're going to use that second type of equation up here. The y plus bx yields by plus x. And I'll go ahead and write that here. Al is now going to pair up with the F, but we want to make sure that that's electrically neutral. We're going to go up to the top. Our charge for Al is 3+, F is 1-. If that's the case, if this is a 3+ and this is 1-, then that means we're going to need 3 total F's to balance that out. And then I can go ahead and erase my charges there. And then the last thing we have is Cl by itself. But remember, Cl is a diatomic element. Therefore, we need 2 to balance that out. Now we're going to go back in and write our coefficients. If we look at Al, Al has 1 and 1 on each side, but Cl has 3 here, 2 on this side. We're going to use the 2 here to get that to 6, and then we can balance that like that. And then we're going to have 2 Als now. If we put a 2 here, my Als will be good, and then now my Fs have 6, and then we can just go back here and put a 3, and then we're all done on that one.